Example 11 is going to give us a little bit of new insight into being able to find the geometric shape that we're going to take the area of. Okay, we should all recognize, let's look at this integral, negative a to a of a minus the absolute value of x. The first thing that you should be thinking in your head is, what shape does absolute value of x produce, right? It's either a v up or a v facing down. Since the negative is in front of the absolute value in this scenario, you're going to be having a v-shaped down, or opened downward. Okay, the a is just a constant. That could be 4, 5, 10, 200, whatever we want it to be. We just need to know that that's where the vertex of this absolute value function is going to be. So to start, take a look at the graph. Okay, I've sketched the graph here. You should be able to do the same thing. Alright, if you struggle with having that variable a there, just replace it with a number. Say, alright, 5 minus absolute value x, or 2 minus absolute value of x. That'll give you the general shape if you graph it on your calculator, so you know what you're looking at, and then just replace that 2 or that 5, whatever you used, with the letter a when you graph it, and that'll give you the representation that you're looking for. Okay, so we should know if we're negative a to a, and this problem might be confusing because there's 3 different a's, right? There's a negative a and a. Well, we need to know that since it's on the integrand, that's the x values. And so if you notice at the bottom of this triangle here, we're going from negative a to a. That's from the integral piece. Okay, the a that's on the y-axis, that comes from the function a minus absolute value of x. Okay, so just so we understand where all those different a's are coming from. And then the area of the shaded region is what we're looking for. That's obviously the area of a triangle. So we have to take 1/2 base times height. Here's what you have to pay attention to. Okay, the base of this triangle, although this is negative a and positive a, this entire base is 2a in length. Okay, and then the height of this triangle, this y value, is a. So the base is 2a, the height is a, so we take 1/2 times 2a times a. The 2's cancel, and we're left with the area of this triangle is a squared. Okay, so whatever that happens to be. If a was 5, it would be 25. If a was 9, it would be 81. So on and so forth. So you'll have 1 or 2 problems on your homework assignment that you'll have to apply. Same with this problem right here. We have to recognize anytime we have a square root function that you are going to have most likely a semicircle or a quarter of a circle type scenario going on. Okay, when we have a perfect square, the difference of 2 perfect squares here. Okay, so you need to be thinking semicircle when we have the difference of 2 perfect squares, right? 49 is a perfect square because it's based off of 7. X is a perfect square because it's based off of x, right? So if we take a look at this integral from negative 7 to 7, alright, well those are important points because negative 7 squared is 49 and 7 squared is 49. 49 minus 49 is 0. That's the 2 points here, alright, where the zeros are located for this function. So this produces a semicircle or a half circle. So that's the geometric shape that we're looking at. So if you were to graph this on your calculator, alright, you'd be able to get this right, this area right here under the shaded region, and recognize that it's a half a circle, and you should be able to see that the radius of this circle is 7. So it's just 1/2 pi r squared, because remember the area of a circle is pi r squared, and we only want half of that, so that's why it's half pi r squared. So you just substitute in 7 for r, so it's 49 over 2 times pi. So relatively easy. Don't get too intimidated by these. Okay, you're going to be able to do them. Just get the shape down, sketch yourself a graph, and if it's numbers that don't show, remember hitting zoom 6 puts your calculator in a standard 10 by 10 window. If it's something that is outside of that, you hit zoom 0, and that fits the actual graph onto your screen. Okay, so just a word of advice when you're doing these. Alright, let's take a look at one of these type of problems. You have 2 or 3 problems on your homework that involve this. We're going to evaluate this integral here from 2 to 4 of 8x dx. You're given 3 values. You're given a specific answer for 2 to 4 of x cubed dx, that equals 60. The integral from 2 to 4 of x dx equals 6. And the integral from 2 to 4 of dx equals 2. Your goal in these problems is to break up your given integral into values that look like the three given ones and then substitute in. So, case B, let's look at this for integral. So we're given the integral from 2 to 4 of 8x dx. So factor out that 8. That 8 can stay in front of the integrand. Alright, when we factor out the 8, we're left with the integral from 2 to 4 of x dx. Well, up here, the middle given value is 2 to 4 of x dx. It says it's 6. So I can replace that entire integral with 6. So 8 times 6 is 48. That's exactly how easy these problems are. You may not use all three of those values. You might only use one. You might use two of those given values, or you might use all three of those values. So don't think that you have to use all three of those given values on any problem. It can change just based on the problem you're given. Alright, so let's look at this example. Same scenario. We're going to evaluate the integral from negative 2 to 4. I'm sorry, not negative 2. That's just a glitch. It is 2 to 4 of 10 plus 4x minus 3x cubed. So that is 2 to 4. Okay? We're given these three values. We're given anytime the integral from 2 to 4 of x cubed is 60, 2 to 4 of x dx is 6, and 2 to 4 of dx is 2. That's the same exact given values as the last problem. Okay, so our solution is we need to break up this into three separate integrals. Okay, the original function. So we're going to rewrite that integral as 2 to 4 of 10 dx, 2 to 4 of 4x, and 2 to 4 of 3x cubed. Don't forget that minus sign there. When we factor the 10 out in front, we're left with 2 to 4 of dx, plus we factored the 4 out of the middle term, so we're 2 to 4 of x dx, minus we factor the 3 out, 2 to 4 of x cubed. Alright, so if we look, the far right integral is 2 to 4 of dx. That's our left integral down here that we're solving. The middle integral, where we factored the 4 out, we're left with an x dx. That's the middle replacement that we're given up here. And then on the far right, where we factored out a negative 3, we were left with 2 to 4 of x cubed dx. Well, that value is the first one that's given to us. So we're able to replace the three integrals that we solved for down here with their given values. Do not eliminate the coefficient that you factored out of the integrand. Okay, so we factored that 10 out. It stays in front, but we replace the integral of 2 to 4 dx with 2 because that was one of our given ones up here. We also replace the integral of 2 to 4 x dx with 6 down here, so that we get 6 times 4 down here. And then we replace the integral from 2 to 4 of x cubed with 60, so it's going to be 3 times 60. So if we look at this down here, we have 10 times 2 plus 4 times 6 minus 3 times 60. So we're going to get 20 plus 24 minus 180. So it's really just breaking down these integrals into, factoring things out so that we can use the given values here and substitute them in to find the area. So we got negative 136 on this one. Let's do one more here. We got example 15. We're going to evaluate the integral from 2 to 4 of x minus 9 dx. We have the same exact given values as before, so I'm not going to retrace through those. But what do we need to do? We need to break our given integral into two different parts. Right? Since we have a difference there, we can write it as 2 to 4 of x dx minus 9. We're pulling that out of 2 to 4 of dx. And then we just replace what's given. Okay? X dx is 6, and the integral of dx is 2. So we end up replacing 6 minus 9 times 2. So 6 minus 18 is negative 12. Okay? Any questions on that? Alright, we're going to go ahead and wrap this one up here. Just want you to make sure when you're doing the homework on problem 16, it uses the letter S. You do the exact same thing we've been doing, and I think problem 18 uses the letter U. Just treat them as X. It really doesn't matter what variable we're using right there. It means the exact same thing. There was just a slight glitch. I think your givens are all in terms of X, and the integral was saying in terms of U. But just make that S an x and that u an x, and you'll have no problems on the homework. It's the same stuff we've been doing. There's just a slight glitch on the homework there. Okay? A couple different special integrals that we just want to glance at real quick. Notice if f is defined at x equals a, we're going to define this value, negative a to a of f of x dx. It's going to be 0, because that's kind of the first scenario we went through. We had a negative area and a positive area. Those two are going to cancel each other out. So that's a special defined integral of 0. If f is integrable on a to b, we're going to define that as, really all we want to do, this is changing the limits of integration. So as long as if we can integrate it on a to b, we can rewrite the integral. So say we're given b to a of f of x. If we want to reverse it and make it the opposite, we can say the opposite, so that's why there's a negative in front of this integral, a to b of f of x dx. So it's really being able to flip the limits of integration so that it works out for us by putting a negative in front of the integral there. Okay? The last part's just notes, properties of integrals. You guys should be able to do this one. We did this when we did indefinite integrals. This k is a constant value. Remember, we can always factor a k out in front of the integrand and then evaluate the integrand. Number 2 here, that's just saying, hey, if we have f of x plus g of x, we can break it into the integral of f of x plus the integral of g of x. Or if we have f of x minus g of x, we can break it into two separate integrals, all right, as the integral of a to b of f of x minus the integral of a to b of g of x. That's exactly what we did in all these example problems up here. When we had to break this, like if we're looking at example 15, we took this one integral from 2 to 4 of x minus 9 dx, and we broke it into the integral from 2 to 4 of x dx minus the integral of 9 times 2 to 4 of dx. That's where we're breaking that up. That's really just applying this last step down here on step 2, where we can write them into individual integrals to help us solve. Well, that sums everything up for section 4.3. Alright, 4.4, we're actually going to learn how to evaluate integrals. Very, very, very important chapter, or not chapter, but section that we're going to run through next. So hopefully these are all helping you guys get through the homework in these times. Hope you guys are all staying safe and taking care of yourselves. So anyhow, I will meet you or talk to you in section 4.